Good to see you all here. Happy to see so many people still interested in the hackathon. So let's go through quickly what we have in store for you, and then we'll see what you have in store for us. So the goal is these are seed projects and prototypes for the Rowan alert ecosystem. As you know, how we were in Rubin space a few months back when we didn't have real data. We're in similar Roman space right now. In 6 months, it'll be launched and we should have real data. The focus is on alerts, something that most of you are interested in. So brokers, classification, data sets, and transition from simulations to real data, of course. And the outcome that we expect is a few teams, maybe some prototypes that come out, and two 90-minute sections are not really good enough for a hackathon. So we hope that this will continue beyond that as well. And there will be some prizes. Don't worry. Okay, so let's go through the what we have today and tomorrow. So this session is happening now. There will be a quick overview of tracks, then some team formation, and then you'll have about an hour for hacking in the official time. But of course, Thursday night is yours, right? Meaning you can do whatever you want and keep on hacking if you want. And that's why we split it over the 2 days. And tomorrow again, we get back here at the same time. Uh, well, actually, you can continue hacking in the rooms that you are in or will be going to in your groups for 60 minutes. And then we get back here at 4:30. There will be short presentations by each of the teams, 3 to 5 minutes. And then that's how we will end. But what we'll do is that various teams that are taking part, we will have opportunities for them to give full presentations at the Stride meeting. The Stride meeting is the Roman time domain group. It meets every first Friday at 10 a.m. PT. And so if you have.
Just a quick correction, Chief.
Yeah.
Friday, it's 2 to
2 to 3:30? Okay. After lunch immediately. Okay, sounds good. Thank you. And so you'll have ways to present it at the Stride meeting, and then there's the quarterly meeting coming up. So there will be a short report that comes out of this hackathon that we will be presenting there as well. So you had the QR code before. You have the web page where you can go and look up things. You should start at the notebook. That's the data overview notebook that gives you details as to where these data come from, how these alerts were made, the cutouts in there, what goes into the real bogus, and so on. Gory detail. You can create your virtual environment in whichever way you want. You can use a VNV or Conda or whatnot. There is a requirements notebook, also requirements file that was there on the box, but I also have and where is Joseph? Joseph, you are here? Okay. He has a USB stick, both USB-C, USB 2, so you can take it from us too or download it directly from there, about 12 GB of data in case you have not done that already. So you'll have more details there. And then there are also some solution notebooks that the TAs have available, and I'll mention who the TAs are for the different ones now, right? And remember that in some cases, there may be some missing data where numbers like 0.5, right, between 0 and 1 are put. So if you directly use it, then it's going to bias your model. So those are the things that we'll encounter in real data also. So keep in mind that that may happen. Okay, Hack Track 1. So how many people have signed up for this, if you have already? Okay, I see at least one hand, two hands. So there are stickers outside, by the way. If you pick them up, then other people can easily see you also. I saw that track 5 got the most traction so far, which is the light curves track, but we'll come back to that. And so Matthew, can you raise your hand, please? He'll be the TA for track 1. And we have about 30,000 alerts. And these alerts are not necessarily all beautiful events. They also have bogus events. They have faint transients, they have stars, they have galaxies. And one of the things is to mainly be able to parse them and see where we can go from there. And the possible output is Roman alert tools for our broker plugins. And some of the challenges that we have, can you improve filtering to identify more transients? Only a few are being identified right now. Or can you incorporate methods that use fewer light curve points if possible? Light curves come later, of course, but the alerts have cutouts and light curves as well. And building a better quality filter and ranking candidates. Hack Track 2 is about detections. And Jacob is the TA for that right here. So detections to generate alerts. And then challenges, can you optimize source detections on rapid difference images to find more real or most reals? Can you optimize the code to reduce false positives? There are They work hand in hand, of course. Can you code to use alternate methods for better detections? It's quite open that way, right? I mean, lots of possibilities. Again, there are some approaches that we have in solution notebooks that the TAs have access to. Act Track 3 is real bogus classification, one of the first things that we need to do. Not a very sexy topic, but that's something that needs to be done anyway. So real bogus classification, but that is what can later on lead to real transient classification. And then comparing classical ML, deep learning foundation models, whatnot that you want, and creating baseline classifiers, benchmark data sets, etc. And so the standard things, can you optimize the ROC curve? Can you cluster bogus events? Can you come up with image-based features that improve the separation? Can you incorporate active learning? How does it work when you filter by filters or by magnitudes, or brighter magnitudes, fainter magnitudes, and so on? So I'll be the TA for that. Act Track 4 is star galaxy classification. Again, an important thing to know whether your transient is on top of a galaxy or not, hostless, with host, whatnot. But again, understanding those is important. And you can start with just stamps, but again, there too, you can use features. How do the features help that you generate or let a deep learning algorithm generate? So here, Ilaria, can you raise your hand, please? Thank you. She's the TA, and Ryan is going to be the floating TA also, but also for this topic. And yes, can you use stacked rapid reference images? Can you come up with image features that separate two classes and so on, right? Then track 5, that's where there are many people who took stickers from outside R. So when will be the TA for that? And how can we work with those? With the direct feature, with the direct light curve, structure functions off of those, derived features from them again. And again, many different possibilities, possible questions that are there, right? So the expected overall outcomes: make GitHub repositories for your teams, prototype tools or notebooks, create benchmarks, broker adapters, initial classification pipelines, teams ready to continue work, whatnot, all of that. And so this is a little bit for the teams and rooms, etc. So this building is the Cahill building. The building next door is the Keith Spalding building. So here, some people can choose to stay here if they want to. Tentatively, we have said it to be the alerts group. We're hoping that more people will likely be interested in that, track 1. And again, the stickers for that are black outside. Cahill 219 is upstairs, roughly in that direction. It's an interesting building, so you'll be able to figure out the rooms. And I think in Slack, Matthew has put some instructions as to where to find those. And even 312 and 319 are roughly in that direction, obviously on the 3rd floor in this building. So group 2 there, group 3 and 4 there. And Keith Spalding is the big room in the next building. Ryan, you plan to go there also, right? Floating, okay. So that's where the light curves group can go. But there are also the 415 in Keith Spalding is a backup room. Some people can choose to go to the patio if they want. If there are other groups, spontaneous groups, for instance, or the patio also. And there is or will be a Zoom link for participation for remote participants that will be put on the Slack. And so the TAs will then make sure that people can connect if they're trying to connect from outside. So TAs should connect to Zoom and see if their breakout room has any people who are remote who are connecting to that. Go ahead.
Just a quick clarification. So the Zoom link that we're using is just the Zoom link for the meeting, and there's 5 breakout rooms, 1 for each track. So you can just use the regular Zoom link and then assign yourself to the track that you want to join.
Right. And in your teams, try to decide on a note taker or a scribe so that you have copious notes. If there is someone who's great at designing, that's really good as well, because then for the presentation, that is really helpful. You can create a shared Google Doc, and then we can all bring the presentations together later on. So you can also choose a presenter if you want, but all of you can be the presenters, come up here as well. And then we will have a shared Google Drive where all those presentations can go in. Any questions so far? Okay, you all seem to be set. So again, let's see, how many of you plan to go to the track 1? Okay, we have a bunch of hands now, great. Track 2, also good. Track 3, okay, at least 3. Good. Track 4, okay, a few. And track 5, oh great, that was the biggest group. Nice, okay. Any questions about where you need to go, what you need to do, etc.? This is again, yeah. This room is the commitment. Yeah, right here, this hall, yeah. Right. Yeah, there are also the color tabs also. All right, so that is all that we had. And so connect with your teammates, with your TAs, continue hacking, and we'll want your presentations tomorrow at 3 o'clock, sometime around that time.